Well, hello and welcome to Math Blossoms, where growing in mathematics is natural. I'm the teacher, Miss G, and for today's topic, we're going to learn how to solve two-step equations. Let's get started. Now, for this video, hopefully you have already watched the one-step equation video because it is a little easier to understand this one if you've already seen the one-step video for those types of equations. For two-step equations, we're going to have two operations to cancel out instead of one. Let's review the vocabulary real quickly. We did this in the one-step equation video, but it is good to kind of review it again. Expressions are mathematical statements that contain at least two numbers, variables, or both, and at least one operation. Equations basically are the same kind of thing, except it has an equal symbol. So remember, the difference between an expression and an equation is that equal symbol. If you look at the picture below, you can kind of see what I'm talking about there. Coefficients are the number or symbol that's being multiplied times the variable. And then the constants are numbers or symbols that have fixed values and do not change, such as the 2 and the 9 in the picture below. And the variable is a symbol, often a letter, that represents an unknown quantity or value in an equation. Terms are single number or variables or both that are multiplied together, or they're separated by plus signs, subtraction signs, multiply or divide signs, equal symbols, or inequality symbols like less than, greater than. So as you can see, 7x, 2, and 9 are all separated by a plus and an equal symbol. So all three of those are terms. Okay, so how do I solve equations? We use the don't call me after midnight method. And so what we do is we start with D and then we move our way down. For two-step equations, however, we're going to only use the last two steps: add, subtract, multiply, or divide. We're going to use one of those for each of those two steps. For instance, if there's addition in the problem, we will subtract. If there's multiply in the problem, we will divide, and vice versa. We also use inverse operations to solve equations in a specific order. And that's pretty much all that I'm going to say about that. Now let's try some, because the best way to learn is to see how to do this and then try some on your own. So this is a two-step equation. I'm just going to go ahead and pull them all up here. All right. Now we're just going to do one at a time. So the first equation here is 2x plus 5 equals 11. So focus on the variable side of your equation, which is where the x is. And first of all, we're going to start by the add or subtract part. Remember, we have to do these steps from top to bottom. So add, subtract comes before multiply, divide. So this 5 that's being added to your x, that's what we need to use an inverse operation on to cancel out first. So since it's plus 5, we're going to minus 5, and that's going to zero that out. And of course, don't forget to do it on the other side of your equal symbol. And here's a good tip. Rewrite your equation after you cancel something out. Rewrite what's left over, because then it's a little easier to see what to do next. This is very important when you get into multi-step equations, rewriting it each time kind of until you get really good at it. It's a really good way to help yourself not be confused. So as you can see, we canceled out the 5. So all we had was 2x on the left side of the equation. And then on the right side, we have a 6 now. Now the last step here is multiply, divide, and the 2 is being multiplied times x, which means we need to divide by that same number to make that a 1x, which is what we want. We want to isolate that variable, which means getting it all by itself, only one of them. And then when we divide 2 on the other side, we end up with a 3. So our answer is x equals 3 for the first equation. We'll switch colors here and we'll do the second equation. This one is 3x minus 7 equals 11. Again, we've got two operations to undo. We have a subtraction here and we have a multiply here. So of course, we're going to start with the constant, which is the 7 here, and we're going to undo or inverse out the add subtract part. And since 7 is being subtracted with our variable, we're going to add it in order to cancel it out. a plus and a minus of the same number, boom, cancels out. Then when I add the 7 to the other side of the equal symbol, I get an 18. And then I'm going to rewrite my equation. 3x is all I have left on the left side of the equation, and 18 is what I have left on the right side of the equation. Now that that's done, I'm going to go down to multiply, divide. The 3 is being multiplied times the x, so that means we need to do the inverse of multiply, which is divide. And we're going to do that on both sides. And that's going to give us a 1x equaling a 6. I'll draw some lines so you guys can kind of keep it separate here. All right, the third one, switch to green here. 1/2 times x minus 1 equals 9. Again, we're going to start with what's being added or subtracted with the variable. And that would be this minus 1 here. So we're going to add a 1 and add a 1 over here. We're going to rewrite our equation, leaving out the stuff that we canceled out. So we still have a 1/2 times x equaling, on the right side of the equation, just a 10 now. And then to get rid of our coefficient of 1/2 here, we need to do the opposite of multiply, because 1/2 times x, that's the operation going on with our variable. And the opposite of multiply is divide. So 1/2 divided by 1/2 is a 1, and we want it to be a 1x. That's going to make that cancel out. And then when I divide the 1/2 into the 10 here, you can use your Desmos, or you can think of it this way. Well, let's use Desmos. I'm going to tell you both ways though. So if I did 10 divided by the fraction 1/2, I'm going to get 20. Now, before I write that down, I want to show you where that comes from. Okay, 10 divided by 1/2. Now again, you can use Desmos. You can just type it in there and get an answer. And we just found our answer was 20. But where are they getting that answer from? When you divide by a fraction, you're really multiplying times the reciprocal of that fraction. So take your 10 and keep it the same. Change your division symbol to multiply, and then flip that fraction around. Okay, that's what a reciprocal is when we take a fraction and we flip it around. And then we just multiply across the top. 10 times 2 is 20. And we multiply across the bottom. This 10 is actually over a 1. 1 times 1 is 1. And that's where the 20 comes into play. So you don't have to do all of this and show all of this work if you're just putting it in your Desmos, but I do want to explain why that works. So remember that dividing by a fraction is multiplying times the reciprocal of that fraction. Another common thing that students use to help them remember that is the keep change flip rule. Because if you noticed on this part, we kept the 10 the same, we changed our division to multiply, and then we flipped our fraction to its reciprocal. So if it helps you to remember keep change flip when you're dividing by a fraction, then feel free to do that. Now this one's different than the one we just did. This one down here, let's change it to purple. This is x divided by 4. This is not a number or a coefficient. This is a coefficient being multiplied times the x up here. But over here, this is x divided by 4. So again, with two-step equations, we've got to undo the add subtract part before we can undo the multiply or divide part. So the inverse of this plus 3 here would be minus 3 on both sides. Rewrite your equation, leaving out the stuff that you canceled out to help yourself stay organized and to help you see what to do next, because sometimes it's tricky to see what to do next with a lot of writing. And since x is divided by 4, the inverse or opposite of that would be to multiply times the 4, and it will cancel that out and just leave us with x. And then 2 times 4 on this side, whoops, that's a times, would give us 8. And at any time, we could plug these answers back into our equations to see if they do work as solutions. So if you have time on a test or something, that's a good thing to do. All right, we've got, oops, I didn't mean to go that far. We've got 2 here, 2 more to do here, and these are just decimal and fraction equations. So we'll go ahead and do those. Start back with red here. Again, we need to undo the add subtract part first. Again, let this guide you. Let these steps guide you. If you know the don't call me after midnight steps, when you're solving multi-step equations that are harder than these 2-step equations, it's so much easier if you know these steps and can just do them in order. So we're just using the add subtract part first. Since 5 is being added to the variable, I'm going to subtract it, do the inverse. And then rewrite my equation, leaving out the stuff that I am canceled out here. 0.8x equals 6. And then I have to do this final step here, multiply, divide. And when I, since this 0.8 is being multiplied times my x, I'm going to divide by the same number. That's going to give me a 1x there. And when I divide on the other side, to keep my equation balanced, don't forget to do it on both sides. I'm going to get, let's pull our Desmos out here. We're going to do 6 divided by 0.8. That gives us 7.5. So 7.5 is our answer. I want to make sure I did that. 6 divided, I'm double checking myself over here on the other screen just to make sure I typed that in right. Yes, I did. Okay. Now, the next one is 1/3 x plus 5. And again, we're going to undo or inverse out the plus 5 here by subtracting 5 on both sides. Rewriting the equation, leaving out the stuff that I've canceled out. We have 1/3 times x equals 6. Okay, and to reverse out this 1/3 times x, we're going to divide. And that's going to give us the 1x, because any number divided by itself is the same number, is a 1. So 1 divided by 1/3, and remember that keep, change, flip rule we were just talking about. Let's do it over here. 6 divided by 1/3 is the same as 6 over 1, turning that whole number into a fraction by placing it over 1, times 3 over 1. This is my keep, change, flip. I kept my 6 the same. I just turned it into a fraction by placing it over 1. I changed my division symbol here to a multiply, and then I flipped my fraction to its reciprocal. Multiply across the top, 6 times 3 is 18, and across the bottom would be 1 times 1, which is just 18. So our answer should be 18. Let's double check ourselves in Desmos. So what do we have here? We've got 6 divided by the fraction 1/3. And yes, 18 is the correct answer according to our calculator as well. Oops. There we go. Okay, so things to look out for. Focus on the operation that is happening to the variable and do the opposite or the inverse. And be sure to go in order with your don't call me after midnight steps, which means the add subtract of that constant needs to be canceled out first before canceling out any coefficients with the multiply or divide. Invisible ones in front of variables or parentheses. Again, that's going to be more important. I think it'll come up more often when we're doing our distributive property, which is the next video up. And then subtracting a negative number is the same as adding a positive number. Don't forget, this gets kids in trouble sometimes. If you subtract a negative, it's the same as adding that positive. Also, remember to solve equations by using the inverse or opposite of the operation that is happening to the variable. Remember to cancel out the constant by adding or subtracting, and then remember to cancel out the coefficient by multiplying or dividing. Remember to simplify any fraction answers or round any decimal answers if necessary. And also remember, if you have time, to substitute your answer back into an original equation to check and see if you are correct. We demonstrated this in the one-step equation video. So if you're confused about how to substitute your answer back in, feel free to watch that video, and I have a little explanation with a little example on how to do that. All right, so I think that's everything, y'all. So great job. And now it's time for me to say it was lovely teaching you two-step equations today. Bye.